Hi everyone. I think that we are just live and welcome to GraphQL Madrid, the very second meetup. I'm super excited to be here. We have such an incredible lineup of speakers and also an incredible special guest today that I'm not going to intro yet because first I'm going to just present the sponsors because without them, we couldn't make it happen. First, I want to invite Sarah from this.media. They are doing such an incredible job with the community. They are having a lot of different meetups. And we can just like leave Sarah to say what this.media is up to and where you are calling from. And thanks so much for helping us to set up the stream because it takes a lot of time. So thanks so much, Sarah.
Yes, absolutely. Thank you so much for having me. So I'm Sarah Renaud. I'm calling in from Sylvania, Ohio. I am the marketing manager over at This.Dot. And so we have two kind of hands involved in this. This.Dot Labs. So we partner with a lot of enterprise organizations, and we specialize in mentorship, consulting, training, and staff augmentation. So if any of you are interested in that, if you want more information, get a hold of us at this.labs.com, or you can just drop us an email at hi@this.co. And then over at this.media, at this.co, we're really passionate about creating an inclusive web. And we do that through free developer resources and keeping up with the evolution of the web platform. And how we do that, we have a ton of articles, podcasts, videos, and the biggest thing is online events just like this. So including our GraphQL meetups, we just got done with GraphQL Enterprise 2020, which Carlos, you were on our keynote panel. We had so much fun that day. Stay tuned for those sessions to be available. We are going to release them in a couple weeks. Just wrapped up GraphQL Fireside Chats with Hasura. We'll be back October 27th. And then the GraphQL Meetup Monthly with Moon Highway, Eve Porcello, and Alex Banks, two of my favorite people. They will be back September 1st. So any of those meetups, if you're interested in GraphQL furthering the conversation, go to graphql-meetup.com. And so excited to be here. So thank you for having us, Carlos.
Thanks so much for joining us. I just dropped the link on the chat so the people they can just see the upcoming GraphQL meetup. That there are like a lot and they're really awesome. So thanks so much for all the effort that you are putting on the community.
Absolutely.
Thanks so much. So yes, I guess now it's gonna be time for a second sponsor. Is GraphCMS, where I currently work, and I'm super excited also to say that they have provided me all the time to organize this meetup and give back to the community all the effort that the community is putting also to us, because we are working and we are using a lot of like GraphQL tooling from open source and all the kind of stuff. So I gotta say like thanks a lot for like GraphCMS to like help us to make this happen. And also they're like really cool because they gave us a nice present for today. So a meetup without swag, it couldn't be a meetup. So today, please don't push to production and just like get some free GraphCMS stickers. I just dropped the link on the chat. So just go to the link and just like fill the form and you get some free swag. So I guess now is the time to introduce our special guest. I'm super excited to have her here. And I'm just gonna intro Shruti Kapoor, software engineer at PayPal. Today is gonna be our master of ceremony. Welcome, Shruti. How are you doing?
I'm good, Carlos. How are you?
Yeah, I'm pretty good. I'm super glad to have you here. Thanks so much for like waking up in the morning and putting a lot of effort to be here to contribute to the GraphQL community events, in this case, all over the world, which is awesome. And I'm super excited that you're gonna be like handling all the meetup today. Where are you calling from, by the way? And what time for you?
I am calling from Bay Area, which is currently fiery Bay Area.
Yeah, that's right.
Oh man.
Are you doing okay? Everything is fine there?
I'm okay for now, yeah. Well, I'm okay. Shouldn't say for now. I'm okay. But the air quality here is bad, so I am on a watch right now. But yeah, thank you for having me. I am super excited for this. We were just talking in the backstage, like this is a series of GraphQL Fridays, like we have all these GraphQL events. And it would be great if we can keep this so we can have like Fridays as GraphQL Fridays. Yeah,
Yeah,
but I'm
like
excited to
yeah.
be here.
I'm gonna write that down and we will chat later. Yeah, of course. And but yeah, how's you been? What are you up to? I know that you were speaking last. You were also being the MC from the GraphQL Enterprise Connect, right? Are you speaking in other like upcoming meetups? I would like to hear a bit about what you're up to lately.
Yeah, I think in August, it has been an amazing month for speaking at GraphQL events. I was at GraphQL Enterprise Connect last Friday. And then before that, I was speaking at GraphQL Summit. I was part of the production panel where we talked about how to take GraphQL to production in Apollo's, in the GraphQL Summit. And that was really great. I am also speaking at a few conferences next month, also virtually.
Awesome.
So I'm excited. I'm really
Well,
excited. I think this is a
that
good
sounds so
time
great.
for GraphQL. Yeah.
Yeah,
Yeah.
this year, next year, yeah. We are not gonna have like on-site conferences, but at least we can
Yeah.
just keep, I don't know, contribute with the community and also having these remote meetups. So that's awesome.
I
Yeah.
miss
So
going to conferences. I love the
yeah, that's
swag.
right.
I would
Yeah,
just like hover around the swag booths.
yeah, that's totally right. So I guess the people, yeah, it's been like 5 minutes to five. So I guess like we can start intro the talk. So I'm gonna just give to you all the control, and I will see you later. Have a lot of fun, and I'm looking forward for all the talks.
Thanks, Carlos. Hey, everyone. So today we have three amazing talks from really amazing people in the community. The first talk is about Dispatch This, using Apollo Client 3 as a state management solution by Khalil Stemler. He's a developer advocate at Apollo. Followed by him is Ryan Chenke, who is a dev rel at Prisma, and he recently released a course on securing React applications. His talk is going to be about tightening the full stack development loop with Nexus and Prisma. And our last talk is going to be about from Sam Julian, which is going to be about becoming a secret agent, securing your GraphQL backend with JWTs. I am really looking forward to all these talks. I think these are really great topics that are currently needed, and there's a lot of demand for these topics. So I'm really looking forward to this. I'll briefly give an introduction of myself. I'm Shruti Kapoor. I'm a senior software engineer at PayPal. I've been working with GraphQL for about 3 years now, and one of my passions besides GraphQL is JavaScript and React, um, and dev jokes. So before I bring in the first speaker, I would like to ask a question to the audience, and I will be checking the chat so you can put comments there. So my first question is, why did the software developer go broke? You can put answers in the chat, and I'll give 10 seconds for answers. So why did the software developer go broke? The software developer went broke because he used up all his cash. I'm my own audience. All right, now I would like to welcome on the stage Khalil Stamler. He's going to be talking about Dispatch This using Apollo Client 3 as a state management solution. Um, a lot of developers understand how to use Redux or React context for state management, but they are left confused as to how to use Apollo Client as a replacement. In this talk, he will break down the responsibilities of a state management solution, discuss when it's worth building your own from scratch, and how Apollo Client 3 introduces new ways of managing local state and remote state in harmony. Over to you, Khalil.
Thank you, Shruti, and thank you for the awesome joke. Yeah, so that was a great intro. So yeah, this is Dispatch This. Apollo Client is a GraphQL client and state management library, and it's the most popular way to work with GraphQL on the client side. It's downloaded nearly 2 million times every week, and we recently released Apollo Client 3, which is a new version a couple months ago. It introduces new ways to use Apollo Client as a single source of truth for client-side state. So I got a great intro. I'm Khalil. Yep, I'm developer advocate at Apollo. I help developers level up with Apollo, GraphQL, and TypeScript. And I'm also pretty passionate about software design principles and best practices. And actually sniped a really cool copy of some books on Shrudi's shelf back there. We're going to talk about that later. But I also love music. And in another life, I'd probably be spending my time just making noise. So today, at least in the React world, some of the most common approaches to client-side state management are Redux, React Context, and Apollo Client. So Redux was very popular for a long time. And I think that popularity came from the fact that it was a very simple mental model to understand. We had reducers, actions, and action creators, and even thunks. And with this, it introduced a really nice structure that even while it had a little bit more boilerplate than other approaches, it was repeatable and understandable. I think that kind of structure really made an impact on the community. When React Context came out, using the use reducer hook, it provided ways for us to keep that same mental model of actions and reducers, but in a way that didn't even require Redux. And then we have Apollo Client, which is a completely different beast. It doesn't use that same mental model, and we don't have that concept of actions or reducers. And I think for people moving away from Redux or people who are currently using React Context, it could be confusing to figure out the Apollo way of doing things, but the great benefit of Apollo Client is despite being different, you don't need to write any of that boilerplate architectural stuff you'd normally need to do with Redux or React Context. So the question really is, how do we decide which one to use? Well, maybe we should first ask, what is it that we need from a state management solution exactly? So first thing's pretty obvious, it's storing state. We need to be able to put state somewhere on the client side, of course. So that may include some remote data that we need to pull in. It may include some local state, some stuff that's not on the server. And we need the ability to combine both local state and remote state and have them live elegantly together on the client side. Second thing is we need to update state. We need to be able to handle what's stored locally, and we need to update it. And sometimes this happens immediately, like after an operation, like a get or a delete or an update if you're using REST, or after a mutation or a query if you're using GraphQL. And lastly, reactivity. After a state's been changed, it's pretty common that we want to notify pieces of our UI that relied on that state that it has been changed and that they should present the new data. Ultimately, these are the three pillars of what you would expect from a state management solution. And all three of these do a really good job of getting it done. Yeah, they all have slightly different ways that they're achieved in each approach, but the high level goal, storage, state changes, and reactivity, they're all realized. So then how do we decide which one to use? What makes sense? Well, state management is complex. There's no doubt about that. And we know that this slows down developers. Sometimes state management code can account for 40 to 60% of a project's code base. And that's a completely made up number, but it's also kind of accurate, if you know what I mean. To better illustrate what I mean, let's look at a 5,000-foot view of what I believe to be a generic architecture for most client-side apps. First, we have presentation components, and they don't do much other than present, preferably in a nicely styled way. And presentation components have UI logic. Render this if you're logged in, or otherwise render this instead. UI logic is responsible for doing something with the data that's coming into a component, and then creating user events in response to things like button clicks, hover states, or key presses. And next, we have our container component. I sometimes call these page components because it seems like it's a page that's responsible for hooking up all the machinery to get the features working on that page. So you might not call it a container component anymore, especially since the advent of React hooks and thinking about everything in terms of just functions or hooks. But the reality is we need something, whether it's a function or a class, to enable reactivity. So something that knows how to get data from the store, and something to enable us to take those user events from presentation components and connect them to the right place, whether that be a React hook, a service, or a Redux thunk, or an action creator. That's what I believe the job of the container component, or page component, as I like to say now, actually is. It's to act as the glue in the middle that stitches everything together. And we mentioned something about a store, right? How does this come into play? So for example, imagine we have a to-do app and we're working with to-do objects. When I click the Edit To-Dos button, it's possible that I might need to reach inside of the store to run some logic that decides what we're going to do next. I call this interaction logic. It's decision-making code that determines what we're going to do next in response to a user event. And that's typically either a command, something that makes a change to the system, or it's a query, something that returns data but doesn't really make any changes. So moving forward with interaction logic, it's often not enough to just perform that operation locally. Like with edit to do, when we want to edit that to do locally on the client side, most of the time it also relies on some remote data. So before we change that data we're seeing on our screen, we want to update data remotely using an API first. So we'll issue an operation like a mutation if we're using GraphQL. And now we get into all kinds of infrastructural stuff. In that fetch logic, we have to handle creating the payload, so turning it into the shape that the backend needs it to be, signing headers to the request, specifying the resource location, sending off the request and getting the response. And then in the state management code, we need to shape the response into the format that the client needs it to be in, attach any local state variables to the response objects, and then figure out a way to uniquely add, merge, and remove data from the store. And finally, we need the UI to update. We need that data to flow back all the way through to the presentation layer. So if you look at this, you'll actually kind of find that this is about half the work. You know, we can kind of see that visually. And at Apollo, we gave a name to this stuff. We believe that this is the work that should happen within the data layer. The data layer holds arguably some of the most challenging tasks that we have to figure out how we're going to address on every client application. And using a bare bones approach like Redux or React Context, you might find yourself creating the exact same infrastructure and solving the same problems in every app. And you might find that that's time consuming. The Apollo client library handles the entire data layer for you. So that's pretty cool. It means we don't have to worry about this stuff. And that's kind of like developer productivity plus. So here's how this works. If you decide to use Apollo client, you start out with all that challenging data layer stuff already addressed. You get an answer for this stuff from day one. And then here's the rest of the things left to do. Not only are the rest of these things here important, but they're what makes your app special. This is the stuff you can't just pull off the shelf. I want to say that there are 3 steps to getting started with Apollo client. The first step is configuring the cache. And that very well might just be to connect to a GraphQL API. Then we need to query for the data we need. And 3, we write mutations to change data. This is great. Storage, updates, reactivity, right out of the box. Apollo client gives us a set of APIs to configure, fetch, and update our client-side state. We just got to learn the APIs. So in Apollo Client 3, we've introduced improvements to each part of the library. The first major improvement is around the cache. We've introduced something called cache policies, which introduce elegant ways for you to implement patterns like pagination, pipes, default values, and local state management. Local state management is actually my favorite part of this newest release. We've improved the story here by retiring local resolvers and replacing them with this new feature called reactive variables. Lastly, we're giving you fine-grained control as to how you get access to the cache. In Apollo Client, there are several different ways to update the cache, and depending on how much control you need, there's an API to address that. The rest of the slides in this talk will be based on a simple to-do app that I've put together on GitHub. It shows how to use the new AC3 features and how to build different versions of a to-do app using local state, remote state, and the old local resolvers approach that will still work in AC3. In this latest version, we made installation a lot simpler. By installing @apollo/client, you get access to all of the core Apollo client utilities and extensions. Here's what we normally do to set up the client and the cache. First, we import them. And then we create an instance of the cache. And then we create the client, telling it where to find our graph and giving it an instance of the cache. And with this basic setup, we can actually pull in remote state using queries and make changes to backend services using mutations. We don't need to do anything special past this point to start working with GraphQL data. One of the first things we could do is pull in a collection of data. We do that by asking for the data we want using a GraphQL query. So we'll come over here to this container component, this active to-dos list. We'll import the query. Then we'll import the useQuery hook from @apollo/client, pass the query into the hook, maybe also handle some async states. And then finally, we can pass the data to a presentation component to be displayed. It might look a little something like this, a list of to-dos rendered like that. So behind the scenes, when we use the useQuery hook, a lot happens. And a lot of work is abstracted away for us. It forms the request, sends it off. It keeps us up to date with those async states, which I actually recently learned there's another word for this. It's meta state. It's state about state. And it also normalizes and caches the response. By caching the data, anytime we ask for it again, Apollo Client's smart enough to just know to pull it directly from the cache instead of making another network request for it. Maybe it's a good idea to understand how data gets normalized and what that looks like in the cache. By default, Apollo Client uses the type name plus ID fields to uniquely identify data. So what we're looking at here is the raw data inside the cache after fetching all those to-dos from earlier. It's relevant to know how the cache works a little bit because it'll affect us when we get into mutations. In this next pattern that we'll explore, creating a new item, we could do so by writing a mutation the same way we wrote a query. There's a small important thing to note here though. See where we're asking for the new to-do? By including the new item in the mutation response, the cache is smart enough to identify that something new was brought in. And anytime Apollo Client sees new data, it normalizes it and caches it. So in a component, we can import the mutation, use the use mutation hook, pass the mutation into the hook, handle some async states again, and then hook this up to receive user events from a presentational component. So let's see what happens. Okay, so we've added this fourth to-do. We hit enter, and it looks like it's getting saved on the server, but it's not showing up in the UI. So something's not quite right here. Well, all right, so let's dive a little bit deeper. In the browser, we could actually see what's stored in the cache directly. So looking into it, we could see that we have all our to-dos here. There's to-do 1, 2, 3, and there's 4 right there. So, okay, so this 4th to-do is there. It's normalized and it's cached, but it's not in our cached collection of to-dos. You can see that this is an array of to-dos that are actually just references to the ones stored flat on the cache. So why isn't this new to-do getting ended to the end of this array? Okay, well, it's because the cache doesn't make assumptions about how we want to update cached collections. So when we did the query to get all to-dos, we created a local copy of some of those to-dos. When the cache sees new data coming in that it hasn't seen before, it will always normalize it. It'll always compute the uniqueness and then add it onto the cache flat. But it will not assume how we want to use that new data to modify our existing cached collections. And this is a good thing. Mutations in deciding how our existing collections stored on the cache should change, well, these are all application-specific operations. To Apollo client, all it knows is that we've invoked a mutation. It doesn't know the specific behavior that we'd like to carry out. Only we, the app developers, know this. For example, an add to-do operation adds to the end of a list. A remove to-do splices an object from the array. And an edit to-do updates a to-do in place within the array. This is a small price to pay for abstracting pretty much the entire data layer responsibility away and left to be handled by Apollo client. So yeah, we need to tell Apollo client what behavior we want it to take when interacting with cached collections after mutations. And we could do this using an update function. So if we go back to our mutation, we can pass in an object as an argument. And then in that object, we can define an update function. The update function is provided with direct access to the cache APIs and the new data that was just created that came back from the server in the mutation response. And what we want to do here is add the new to-do to the existing array. So we'll pull the new to-do from the response. We can use an API called read query to execute a query to get the existing to-dos from the cache. And then we'll use the opposite, write query, pass in the query that we want to set the new value of, give it the new data, which is going to be an array, of course. But this time, it'll be all of the to-dos that were just there, plus this new one that we just added. So let's try it out. Let's see what that looks like. Great. It works. So we can see that the to-do is not only saved to the backend, but it triggers a re-render of the view, and we can see that the list of cached items was updated. And if we look a little bit closer, we go back to our cached collection of to-dos in the console, you can see it's there now. So when we're writing this update logic, we generally recommend that you use the read query and write query APIs, because with these, you can accomplish about 95% of what you'll ever need to do here. But with AC3, we also released a set of new advanced cache manipulation APIs that you could also use, and you can check those out on our AC3 docs on cache.modify, cache.evict, and the garbage collection API. So now let's talk about local state management. And this is my personal favorite improvement from this new release. If you were to look at our docs on local resolvers, the old AC2 way to perform local state management, I think you might find that the API is a little bit verbose. And this is actually what we've heard based on feedback from the community. While it was generally liked that local resolvers shared the same mental model of how we implement resolvers on the server side, came at the cost of writing a little bit more code. So we wanted to improve that. We're phasing out local resolvers. They still work, and they'll still continue to work in AC3, but it's interesting to know where they came from and why we're moving away from a technical standpoint. Local resolvers borrowed ideas from this package called Apollo Link. They're wrapped around the cache in a way that when we resolve data, the cache itself wasn't really sure if fields were being resolved from remote state or from local resolvers. And that kind of made it hard to trace. So we aimed for something more reliable and predictable in this new approach. This new approach, which is constructed from the ground up, is called cache policies. Cache policies let you dictate for a particular type and for a particular field within that type what the cache returns before reads and before writes to that field. There's a ton of features packed into this thing, but I'm most excited about the fact that it introduces cleaner patterns for local state management, things like pagination, pipes, filters, and several other common problems that we need to solve when building client-side apps. And the API is pretty light, and it helps us write much cleaner, less repetitive code. So here's an example of a common pattern, initializing a default value. So here we have a cache policy. So on any instance of the person type, on the field name, for that field name, when this is read from the cache, if there's no value set already, what we'd like to do is set it with the default value of the string unknown name. Otherwise, we'll just return it with the value it already has. This is a very basic example, but there's another new feature that cache policies can be combined with that makes local state management a lot more enjoyable to work with. And that's reactive variables, a new AC3 feature. These act as containers to variables that we'd like to enable cache reactivity for. When we change the value of a reactive variable, it'll notify the cache, and if it's being watched, it'll trigger a re-render if you're using React. This means that reactive variables can be changed from wherever you want, however you want, and that's a huge improvement over having to do all your local state management updates in local resolvers. Let's say we wanted to build the entire to-dos app from scratch using local state only. It's a lot easier to do that now. Maybe first we'll define the structure of a to-do type in TypeScript. Do some more data modeling here. And then we can set up what we want the initial value to be. In this case, an array of one to-do. And then let's create the reactive variable, to-dos var. And we do this using the make var function. We could pass in the initial value at the time of creation as well. And then let's go over to our cache policies where we can hook it up. So on the query type, anytime we ask for all to-dos, the to-dos field in our schema, return the current value of the to-dos var reactive variable. This right here is how we connect reactivity to the cache. If we were to go over to another part in our app, we can write a query for these to-dos. And in Apollo Client, the way to tell the cache to try to resolve certain types of data from the cache only and never from remote state is to use the @client directive. So this here will only ever attempt to pull to-dos from the local state. And then we could do the same thing we've done here, pass a query into our useQuery hook and fetch that data and then give that data to a component to display. Now, let's talk about mutations. Instead of actually writing mutations the same way we write queries, we have a lot more say over how we want to update our local variables. So the truth is, we could do this however we want. We could actually use simple functions now. In this example, we have a delete to-dos function that, when composed with a to-dos var reactive variable, it gives us a function that enables us to delete a to-do from local state using the ID. So invoking the to-dos var gives us all the to-dos. Then we could filter by ID to create a new list of to-dos without the one we're deleting. And then we could save it back to the to-dos var reactive variable and trigger a re-render by passing it in as an argument. So again, in case you're sleeping, it's these cache policies and reactive variables used together that gives us a much better local state management story. And I think that's pretty cool. There's a lot of cool stuff in AC3, and I'm just barely scraping the surface. So what have we learned here? We learned about the 3 basic pillars of state management solutions. That's hold state, make it possible to be updated, and making sure that things are reactive. We also learned that this is about half of your client-side architecture. We call it the data layer. And it can be pretty complex to build and maintain it. So that's why we wanted to do it for you. So you can focus on that stuff that actually matters. And if you use Apollo, there's 3 things you need to know how to do. One, that's configuring the cache. And we've seen that there are a lot of new APIs to make local state management a lot more enjoyable. Then we need to know how to fetch data, both local and remote data using queries. And we mutate that data using mutations. And understanding a little bit about how the cache works under the hood is helpful because now we've traded in building this entire architecture every time for just knowing how to use the APIs that handles it for us. So depending on where you are in your journey, there's different ways you could get to where you need to go. For example, I always recommend that if you're getting started, stick with the read query and write query APIs to implement your update logic. And then look into the new cache.modify and cache.evict APIs for how to get more fine-grained control over the cache. So there's some resources here in the docs I'll share for you. And I just want to say thank you. And you're not alone on this journey. If you have any questions at any point about using Apollo Client, you could always reach out and chat with me on Twitter, even if just to hang out. Thanks again.
That was an excellent talk, Khalil.
Thank you.
I learned a lot. I love the evict and the garbage collection, especially the last summary that you gave for people who are sleeping, which I was not.
Yeah. I had to put that there. You never know. It was early here at one point. It's probably early for someone.
Exactly. Yeah, I think that was awesome. We also have questions from the audience, from Victor Morella, who says, any plans to integrate with React Suspense?
Oh, yeah. So I think I talked with the client team about that several weeks ago. I think there is plans to do that at some point. But I think right now we might be focusing on some other things, but it's definitely on the radar. So I think maybe we should check back on that in a little while. I'll definitely raise that though, because it is something that I've heard about that we want to do.
Cool, awesome. And I think that's all the questions, but Khalil, are you going to be hanging out in the chat if there are any more questions?
Yeah, I will. So if anyone has any more questions, I could definitely see what I could do my best to answer them.
All right. Thank you, Khalil, so much. That was an excellent talk.
Thank you, Shruti.
Yeah, that was a really, really, really nice talk. I really enjoyed it. And I think AC3 has a lot of powerful features to help the graphical clients at catching work, right?
Yeah, totally.
Yes, I think now we have some time to do another dev jokes, and if you want to make another question and just give some seconds to the audience to try to answer it, that'll be awesome.
Okay, I have a question. Why did the React class component feel relieved?
Wow, that's a really good question. Though I'm gonna just give some minutes for people to answer on the chat. But I have a question for you, and I would like to ask you what day is today?
It's
Oh, that was a good one. I didn't expect that at all.
I think this song is gonna become GraphQL's signature song.
GraphQL Fridays. We're gonna make that happen.
Yeah, exactly.
Yeah. So we don't have any question, but I think guys that you can go to answer maybe the dev joke. That'd be also great.
I'll ask the question once again. Why did the React class component feel relieved?
The class component feel relieved. Because is there any constructor? No, that's not gonna be. That's not. Not sure.
Because it was off the hook.
Of the okay, that was a good one. Because component is mod. Okay, answer was okay, that was a good one. So I guess like now we can go to the next talk, maybe to let me just like put the intro, tightening the full stack development loop. Good, next one, Prisma. But please do make an intro to Ryan and just like we can start his talk.
Sure. Let's have Ryan on stage. Ryan is a DevRel at Prisma. Hey, Ryan.
Hello.
Ryan recently released a course on securing React applications at reactsecurity.io. I will put the link in the chat. So in today's talk, Ryan is going to be talking about tightening the full stack development loop with Nexus and Prisma. Developing a real-world full stack app often involves tedious threading of data across multiple layers of the stack, and this is particularly undesirable during prototype phases, where the main goal is just to demonstrate an idea or design. So in this talk, Ryan will show one solution philosophy and type safety dilemma via Nexus combined with Prisma. Welcome, Ryan.
Thank you. Thank you so much, Shruti. Hello, everyone. So yeah, as Shruti said, my name is Ryan, and I'm working in developer relations at Prisma. Prisma, you may be familiar with if you're in the GraphQL world, because you may have known of it from its early days, its inception, as GraphQL. GraphQL was kind of like this backend as a service, which gave you a GraphQL API based on a schema that you would create, and you could manage all of that in like a user interface and have a database that would give you data that's exposed with this GraphQL API. That's changed now. So we no longer do that sort of thing. Instead, Prisma, if you go to prisma.io, we give you tools to make working with databases easier. And so what that looks like is a set of tools. There's a whole bunch of things that go into Prisma, but one of the things that you would find with Prisma when you first start using it is you would find things like this. You would find this thing that looks like an ORM. We don't really call it an ORM, but it's this client that you can use to create data and read data and interact with your data in every way that you would want to. And instead of you writing SQL queries or doing manual queries yourself, you have that taken care of for you. And the really nice part about it is that it is all type safe. So that's really where Prisma shines, is that it becomes very difficult to make an invalid query. You have a database client that is really mapped well to your actual data structure. It's difficult for you to do invalid queries with that. So Prisma, not directly related to GraphQL anymore, but of course, you are probably going to need to access data from a database to serve the queries that your GraphQL clients make to your GraphQL API. And Prisma can come in handy when you're doing that. In fact, we're still somewhat involved in the GraphQL community with various tools that we author and help author. One of them that you'll probably have heard of, perhaps, maybe not, but maybe you've heard of it, is Nexus. So there's this tool called Nexus Schema, and this gives you a way to write your GraphQL APIs in a bit of a different way. And when I say different, what I mean is that I think when we're coming to GraphQL and we're getting started with it, we probably see something like this. This is an Apollo server, and it's doing things in an Apollo server kind of way, right? So we've got a set of type definitions. We're using this GQL tool coming from Apollo server to give a string, which is our type definitions. That's a schema for our database. For our GraphQL API. And then we map up a set of resolvers. We tell our post query, for example, how it should resolve, what it should do when a query for it is made. And in this case, we just send back a couple posts in an array, or a list, if you will. And then we create our server. So, this is what might be considered the canonical way of doing a GraphQL API, mostly because this is one of the first examples that we see. But this isn't the only way of doing it. And what I'll show you today is one way that we like to do things and how we keep things type safe in the process. So I'll show you how to think about writing a GraphQL server using Nexus schema. And it's a bit different. It works in kind of a code first way, is what we say. So instead of writing a schema using the schema definition language and then writing a set of resolvers, you do everything all in one shot with code. So no use of the SDL. You do it all in code, and then you can make your queries to your GraphQL API as you would. So this API that we've got here is working. We've got a couple posts coming back. So why don't we start by changing this up for a Nexus schema-based API. And then we're going to bring in Prisma. We're going to see how Prisma kind of ties in with this and can make the whole experience quite nice. So what I'll do is I'll come into a new terminal here, and I'm going to install Nexus schema. So we'll do npm install at nexus/schema. And so that's going. And what we'll do now is come down here. I'll just kill that so I can restart it once I've got things going. I'm going to import things from Nexus schema. I want to import something called object type and something called make schema. Comes from at Nexus schema. So the idea with Nexus schema, what you're going to do is you're generally going to use this tool, object types, to describe the shape of your API and also tell it how it should resolve with data. So what we can do to start out here is we can come down and let's give ourselves a post type. We can say we want a constant called post, and that's going to be an object type. And there's going to be a couple of things to configure here. We need to give our object types a name. So much like we would give our post type here a name of post, we can say that for our object type, the name is post. And then we want to give it some definition. So we've got this method called definition. And using this T argument here, we can set up the various fields that we would have for our post. We would have an ID. So generally, all of our data is going to be keyed by an ID. We'd have a string called title. So that maps up to our title down here. And then finally, a string called body. Oops. String body. So there is our post type. What we would have to do is give ourselves a query type. So much like we would do in our schema definition language and then map up in our resolvers, we'd have an object type for query. So we'll give that a name of query and then definition on that as well. In the definition here for our query, we're going to say that we want a list of a certain field. And we're going to call this post. This is going to be the query that we make to get access to this data. We're going to say the return type is post. And then finally, this is the exit point here. We want to resolve with something. And just like we would resolve with some data down here in our kind of Apollo flavor resolvers, we can just grab this array. Let's copy this over here. And let's resolve with that data. So the resolve function here, it's got the same kind of signature that you would see in your Apollo resolvers, right? Your parent, your args, context, and info. So that stuff is there like you would expect, and you can do the same kinds of things you would expect with an Apollo server. Now, the kicker here is that this is all actually going to run through an Apollo server. So with Nexus schema, you can run it through any server you want, really, any kind of GraphQL server you want. You just have to make sure that you can do something like this, where you would give yourself a schema, which calls make schema, which comes from Nexus schema. We've got this make schema import. So with make schema, what we're going to do is we're going to provide it a set of types. The first type that we can give it should be post and then query. So those are the definitions of the object types that we've described above. So we've got our schema there. Let's pass schema now to Apollo server. We still have this Apollo server set up. So we just pass it our new schema, which is using these two new things we've created with Nexus, and we should be good to go. We can do npm run dev. See if we get this running for us. And back over here, if we hit go again, we're still getting things coming through. Let's just prove that out. Yep, we're still getting our posts. So this is pretty cool. What we've got now is, instead of having separately managed schema definition language files and separately managed resolvers, both things kind of take place in one go. So we've got everything happening schema definition wise and resolver definition wise happening in the same place. What you might be wondering is like, well, how does this actually, benefit you? What benefit does this have? A lot of people like the fact that you don't have to hop between files to do those things. But more so than that, what you get with Nexus is some really neat things for strongly typing your whole app. So what we can do here, when we make a schema, we can set some outputs. And on the outputs, we can say we want to output our schema. And here's what we'll do. We'll put it in dir name, generated, and let's go to Nexus, and we'll go to schema.graphql. And we'll see this in operation in just a second, but we also want to output something else, which is going to be type gen. So type gen, as the name implies, is going to generate some TypeScript types for us. Say that'll be called nexus.ts. So if we save this, right away what we should see is our types being generated. So we come up here to our generated file. Let's take a look in here. We've got schema.graphql. And this is taking the API that we've created for ourselves here with object types, and it's giving us some schema definition language automatically generated for us. So that's really cool, because now we can use this GraphQL schema definition language, and we can put it, we can use tools like we get in VS Code, where we get some kind of IntelliSense for our GraphQL clients to be able to know which fields each of these types might contain. And so that makes things easier for our client-side developers. We also get our TypeScript types. So this is very cool, because now we have a way of strongly typing our application. We can pull in these types, and we can say that they have to abide by what has been generated for us here. And we didn't have to do any extra work for that. There was no going through and manually creating those types. It's just everything is generated. So that's very cool. So we've got static data here. What we should do is hook up a database, and Prisma really shines here. Let's see how we can hook that up. So coming into a new terminal window here, let's do npm install, and I'll save one thing. It'll be the Prisma CLI as a dev dependency. Prisma CLI, set of command line tools for you to create your Prisma project, manage it, run migrations, that sort of thing. And then as a regular dependency, I'm going to install @Prisma client. So Prisma client is the place where you interact with your database, really, when you're using Prisma. You're going to create a Prisma client. It's going to have all the type information for your database based on a model that you create, and it's going to give you lots of tooling to make safe database queries. First step, if we're doing something with Prisma, is Prisma init. So we do Prisma init, and over here we have a new folder called Prisma. A couple files that come with it, an environment file. It's got like a hard-coded database URL. Defaults to Postgres, but Prisma supports lots of stuff. So we got Postgres, we've got SQLite, MySQL. There are some more. Head over to prisma.io to see all of the options there. Nothing for NoSQL yet. So if you're using things like Mongo, nothing there yet, but there are plans in the works for that to support both relational and non-relational databases. And what's cool is if you have multiple different databases, maybe they're in different flavors, you're going to end up with a common interface for all those databases. So I'll change up my string here. I've got a Postgres database that is running in the background here. Let me just switch things up so that I'm pointing to it. So that's my database URL. And now in schema.prisma, this is a file that uses the Prisma schema language, the PSL. And you use it to describe what your data should look like, what your database should look like. The first thing you might be interested in would be a model. This is going to give you a table in your database. So you'd want to set up a model called post, for example, if we're dealing with blog posts. You'd want an ID. An ID, in my case, I'm going to say that an ID should be a string. We're going to mark it with an ID, the ID decorator here. And then we want to have it default to something. And I will have it default to a CUID. So this is kind of a collision-resistant universal ID. You've got the option as well if you want to use a UUID, so universal unique ID. The CUID is a bit shorter. I like to use that one. What else? We need some fields, some columns for our table. So let's have a title. And that's going to be a string. And then body will be a string as well. Oops. Go. You get auto formatting with your Prisma schema files if you've got the plugin installed with VS Code. So on save, it's going to auto format for you. It does much more than that too. When you are setting up relations between different tables, you're going to have some automatically generated code run. You're going to have some code automatically generated for your file when you save it. Okay, so that's all we need for our Prisma schema file. So what we want to do now is generate some migrations. And I'll show you the API here. This is under an experimental flag, subject to change. So, with anything experimental, we say use with caution. But it would look like this. You would do Prisma migrate save and pass the experimental flag. And oops, it looks like we have not saved this. There we go. So I had to save my environment file because that user didn't exist. But yeah, Prisma migrate save experimental asks for your name for the migration. I'm going to say this is the initial migration. What gets generated from that is this file here with some information about your migration. In the README, you'll see what the SQL basically looks like for Prisma to create the tables that will go into your database based on your model. So with those migrations in place, we can run them. We can do Prisma migrate up, run the experimental flag, of course. And now if we go over to our database here and refresh, it might be hard to see. I don't think I can zoom in on my Table Plus client here, but we've got post, we've got migration. So migration is a table that has information about the migrations that have run and their status, etc. But we've got our post table. So that's ready to accept some data. So what you could do then is over in server.ts, we could start using the Prisma client. Well, let's import Prisma client from @Prisma client. And let's get an instance of it. Const Prisma equals a new Prisma client. All right. Now, under different circumstances, I might show you how to do things where you put your Prisma client onto context for your Apollo server here. So you might do something like this, where you have your Prisma client. Oops, not context. I meant to say Prisma. You have your Prisma client on context. And with that, you could then pick it up on the context argument, right? So if you got args and then context, you could pick up Prisma on context. But I've been fighting with this thing this morning here, and it's not giving me the type hints that I wanted to when I run it through context. So in lieu of that, what we're going to do is just use Prisma kind of directly here within our resolvers. But normally you would kind of pick it up off of context after you set it up. Could be some issue in the version of Prisma matching not being the most recent in Nexus schema. I'm not too sure, but in any case, what we could do when we want to resolve with some post data now is we could say Prisma. Looks like it's not giving me any type hints, and I wonder if it's because we need to generate Prisma generate. And I will just restart the TS server just to be safe. Prisma. There we go. So this is, where a ton of the benefit of Prisma comes in, is you get this strongly typed database client that gives you things like IntelliSense, and it gives you auto completion and this sort of thing. So you can look for what's available on your Prisma client, and I have posts available because I've described that on my model. And on posts, I've got a number of methods that I can call. And maybe if we're trying to resolve all of our posts, we can just choose find many. And so let's save that. And now if I go over here and I hit go again, I've got no posts. I should expect that because there's nothing in the database yet. So we can actually go and create some posts, and maybe let's do that next. Let's go over here. We'll work with a mutation now. So we've got our post object type that describes our actual, our object type with the fields that we want. We've got a query with one query that we can make to get all of our posts. And what we would want perhaps now is a mutation. So const mutation equals an object type. And we'll give it a name of mutation, and we'll give it some definition. So when we're dealing with mutations, things look a little bit different, I suppose, than you would see with if you're setting this up through your SDL and your resolvers. There's a few more keys that you might work with here when you're creating. So you could do t field and call it create post. So that's going to create a single post. And then you would pass an object to give it some configuration. The return type will be post. So whenever we create a post, we want to have the client be able to query for information about that post. So the ID, title, name, etc. We want to take some arguments, right? So from our clients, our GraphQL clients, we want to be able to take in some arguments, and we'll want title. That's going to be one of them. That's going to be a string arg. This is an import from Nexus schema, string arg. And that's going to now allow us to take a string arg. We want to say nullable is false. We don't want to allow that argument to be null. It has to be there. So that'd be like putting the exclamation point in your schema definition language to say that a field is required. So title, and we want body as well. Okay, we've got our arguments. We also want to resolve with something. Arguments come here in the second position. We can destructure them out. We can have title and body. That's how we pull those arguments off. And we can have context. In this case, we're not going to need it. Again, I would normally be using Prisma through the context argument there, but today we'll just use it kind of directly. And we will, I've got to do that. We will straighten things out there. We will return Prisma post, and then we've got create. So we've got this create method. And if you're looking, like if you're using Prisma and you're like, I'm developing against the database, I want to create something or read some data, and you don't really know what's available there, you can do Control Spacebar. And that will give you a list here in VS Code of what's available to put in. So the first one is going to be data. When you're creating something, data is an object. And then Control Spacebar again says, okay, I've got two things I can put in here. Title, so my first post, and the other one, body. Okay, cool. So we've got those now. And let's see. So we're returning that. I'm going to just get rid of this here. And why don't we see if we can get this to go for us? So, in fact, instead of hard coding this in here, why don't we just use title directly from the client? We'll do that instead. It'll take title and body as arguments. Okay, so over in our playground, let's run a mutation, and I'm just going to refresh so we make sure we've got the make sure we know about our API. So create post, and it looks like it's not giving me what I would expect. So I just wonder if there's anything I need to do here. Just wondering if there's an error. I want to check my schema. So it didn't generate for me in my schema here. And I'll double check here what we've got. I see. It's because I did not yet put the mutation into my schema. So I defined it, but I now have to put it down here into my types array for my schema. So saving that now and looking into schema.graphql, now I've got the mutation with create post. Okay, so back over here, we'll try this one more time. We've got create post that needs a title, my first post, and body. First post, body. And then I can get some info back. I can get ID, I can get title and body. And let's hit go. There we go. So we've got an ID, title, body. In our database, if we refresh here, we can see that first record. It's hard to see again because everything is so tiny up there, but there it is. It's in our database. And now if we were to query for our data once more, and we could say post, ID, title, and body. There we have it. We've got our post coming back. So that's a really easy way to work with your database. Prisma gives you everything you would want. Now, there is a lot of stuff you could do to sort of tie things in between Nexus and Prisma and get things like CRUD. So CRUD resolvers are something that are offered through Nexus Schema. And with that, you can have automatically generated resolvers for you. So if you had a resource, say you had like a, well, the resource that we have here, which is our post table. If you opted into this experimental feature, it's marked as experimental, but you could have CRUD resolvers, which would give you things like create one post or find many posts, these kinds of things, right? So that is a productivity boost for sure, especially, you know, getting back to the heart of the topic here is when you are experimenting, when you're prototyping, you want to move quickly, and having tools like Prisma and like Nexus helps you to ultimately write less code. That's sort of the goal here. Write less code, do more stuff with that code that you write. And so if you're prototyping, you move quicker. It allows you to move much more quickly. And you also get the benefit that you're type safe. And you get this kind of for free. Like this is, as long as you're writing TypeScript, as long as you're using .ts as an extension, you get a whole lot of benefit here for free. And it just so happens that those benefits start to come in handy when you get past the prototyping phase. When you're going to production, when your application starts to get larger, when you have more team members coming on, all of those things, you're really going to benefit from the type safety that you get from Prisma and from Nexus. So once again, Nexus is a different approach to writing your GraphQL API. It's different in that you're not using the schema definition language to write how your API is shaped, and then writing a set of resolvers to describe how data comes out of your API. Instead, you do that all in one shot, like we've done here. And then Prisma, it's a great tool set for your database. It maps up to all sorts of relational databases, and you get your types generated for you. One thing that I'm realizing I didn't show, which I'll show quickly here, is like, how does Prisma know about the typings for your database? If you go into node modules and then into the .prisma file and then index.d.ts, this is the type generation file that Prisma handles. So we could look for type post, for example. And here is the type for our post model that we created in our Prisma schema. And then there's all sorts of other types that get generated automatically, like how you can query your database. So like where, you know, that's a certain clause that you would use for database querying, all sorts of other things, lots of really cool stuff in here. So I invite you to check out prisma.io. That's where you'll find lots of really cool stuff about Prisma. The Nexus stuff, you can go to nexusjs.org to check out how Nexus and Prisma can be used more closely together. Here's me on Twitter. This is where you can find me at Ryan Chenke. And come say hi there. DMs are open if you want to say hi there. And as Shruti mentioned, I've got this course on React security. So I just recently launched this. If you're doing React and you're interested in how to secure your React application, you can come check out this course. I've got like all sorts of information about JSON Web Tokens, how you would set up security for your app, etc. So that is about it for me. I think there's a couple of minutes left, so happy to take some questions as we wrap up here.
That was an excellent talk, Ryan.
Thank you.
I love the tricks. The part that I especially love was automatically generating resolvers, such as like create one post and find many posts. And I oftentimes find that I have to create those by hand. So I think that's really neat that it automatically generates it for you.
Yeah, totally. Yeah.
I noticed you're wearing GraphQL swag.
I'm wearing GraphQL swag. This, yeah, that's right. This is I have like 3 of these shirts, and so if people see me on live streams, etc., and it looks like I wear the same shirt every day, I promise I have three of these shirts.
I love it. You're in the GraphQL theme. I love it. So we have questions from the audience. I will ask it away. The question is from, I apologize if I butcher your name, Ruari Odeno. This looks great. Makes schema far more manageable. Any migration tool to parse and convert existing Apollo schema to Nexus schema?
Existing Apollo schema to Nexus schema, there is something. I am blanking on the name of it and where exactly you would find it, but I'm almost certain that there's something to help you manage that. There's a tool. So send me a message on Twitter or elsewhere, and I'll get you situated with that. But there's something that helps with that process. I'm like 99% sure.
Cool. And your Twitter handle is Ryan Chenke, correct?
Yep, at Ryan Chenke on Twitter.
Awesome. And there's another question, which is, what would be the pros and cons of using code first versus schema first with Nexus and Prisma?
Yeah, so one con, and this is something that we've heard, is that the schema definition language can be a little bit more approachable especially for newer GraphQL developers. So if you're working on a large team and you've got developers of various skill levels, all approaching GraphQL, developers of different experience levels, you might benefit somewhat from having the schema definition language be sort of your entry point into making your GraphQL API. And that's because it's easy to read. Like I think one of the things we all love about the schema definition language is we can start to reason about the shape of our API quite simply just by looking at the SDL file. Now, when you're looking at your Nexus object types, it becomes a little bit trickier to see how everything is shaped. Now, the benefit you have is that you can look at the generated SDL files and get a sense there of how everything is shaped. But I think that's maybe one downside, is like code first maybe is more interesting for developers who really have a good grasp on GraphQL APIs, how to build them, and maybe GraphQL APIs that they built with schema definition language first approach in the past. But there's a lot of benefit that comes because you don't have to manage these 2 separate files. You don't have to be hopping between files. Things just happen all in one go. And it's a reduction in code footprint too, ultimately, when you switch to code first.
That's great tips. There's one more question, which is from Ramyak Mehra. Is there any admin panel available for Prisma?
Yeah, so you can do, I wonder if I can just make double sure about the URL here. There is an admin panel. Do a Google search for Prisma Studio. And what you'll find is it's basically like an IDE for your database. So you can think of it as a more modern PHP MyAdmin. If you have a Prisma project, and I believe the command is something like Prisma Studio, something like that. There's a command, I can't remember exactly what it is, but you can run it in your terminal, and it's going to pop open an admin panel for you. You can manage your data through it. Do a search for Prisma Studio, and you'll see what that looks like. It's a really nice, kind of modern, sleek admin panel for your database.
PHP MyAdmin just brings me back memories.
Yes, me too.
All right, I think that's all the questions that was an amazing talk, Ryan. Thank you so much.
Thank you.
And
awesome.
You would be hanging out in the chat, correct?
Yeah, I'll be around.
Awesome. Thank you, Ryan.
All right, bye-bye.
Bye.
That was a really, really good talk. I guess like a.
I think you're on mute, Carlos.
I am mute. What?
You're good. You're good.
Great. Awesome. Thanks. Yeah, I think it was a really good talk. I really enjoyed it. And I feel like there are like a lot of work during the years, over the years of the Prisma team, like iterating about this product. And it's great. So thanks a lot, Ryan, for coming in. It's a pleasure to have you here. I just dropped the link for the Nexus converter, and it was super fun because I was kind of like contributing with Tim Grisser, which is the creator of Nexus, to make this happen. So that was great because you can pass your URL and you're going to be able to convert from SDL to Nexus schema. So that was a fun project to work with. But I guess like now we have more dev jokes, I hope. That'd be great.
Yes, we do. Okay. Next question. What did the constant say to variable when they broke up?
I knew this one. Let's give some time for people. What it was. Can you repeat the question, please?
What does the constant say to variable when they broke up? And I will give a hint. If you want to know the answer, you can go check out my Twitter at ShrutiKapoor08.
That's great. Okay, let's give some time. But now I gotta say that I'm super glad that it's Friday, and I'm super excited for this weekend.
Hold on, hold that thought. Yeah. Oh my God, I'm so glad it's the weekend, honestly.
This is being awesome. I'm not sure if we're gonna be able to repeat this meetup.
Khalil says, "Is that Pitbull?"
I wish. Yes, I don't remember the answer for that dev joke.
What did the constant say to variable when they broke up? Let me see if chat has any answers so far.
It does not have. You can go for it.
Ramyak says, "I'm not gonna change. I think we have a winner."
I'm not gonna change. That's good. Oh, that's great. Oh, that's great. Okay, so Ramyak, right? It is gonna be the winner from the Rap to GraphQL book because he answered like correctly the dev joke. So, that's awesome.
Yay! Good job, Ramyak.
So Ramjat, I'm gonna like hit you up to get the book, and I guess like now we can go for the very last talk of the day. It's been such incredible like talks, by the way. I really enjoyed the meetup. But yeah, you can go and intro Sam Julian developer advocate that out here, and he's gonna be talking about becoming a secret agent, securing your GraphQL backend with GWTs. So that's gonna be awesome.
Yeah, I'm excited about this talk because this is exactly what I'm doing right now at work, which is like how to secure your GraphQL backend with JWT. So I'm excited about this talk. But we can have Sam on the stage, and Sam is going to be talking about the same thing, becoming a secret agent by securing your GraphQL backend with JWTs. And this is a special day for Sam because Sam just bought a house.
That's true.
Congratulations,
yeah.
Sam.
Thanks. Yeah. Literally like an hour and a half ago. And then, so I'm coming to you from the Egghead office in Vancouver, Washington.
I think your voice is not coming in, Sam.
Oh no, hold on. It was working before.
Or is it just me? Damn, is it me?
Hello. Yeah, I mean, it says it's coming through. I don't know what to do. I have signal on my side.
Okay.
Oh,
anyway,
Sarah said
I will
we can
give the
hear
stage
you.
to you. But before
Oh,
I
okay.
give the stage, I wanted to give an introduction of you, Sam. So Sam is a developer advocate at Auth0, and Sam lives in Pacific Northwest of America, just like me. And Sam has a new course on using Apollo with React, which I will leave a link in the chat as well. In this talk, Sam will demystify auth while learning how to use JSON Web Tokens with GraphQL API. He will show how to handle authorization in your GraphQL server. Sam says by the end of this talk, you'll feel a whole lot better about tackling auth in GraphQL, and I'm looking forward to it. Over to you, Sam.
Awesome. Great. Okay, let me start my presentation. Hopefully you can see. Okay, awesome. Well, I'm really, really thrilled to be here with you all. We're going to talk about securing your backend, your GraphQL backend with JWTs. Hold on, can I move this? You know what? I'm going to click hide on that and then do this again. And that way, that goes away. Okay, so we're going to talk about securing your GraphQL backend with JWTs. And this talk was inspired about sometime last year. I guess they're almost a full year now. Hasura came out with this article on the ultimate guide to handling JWTs on the front end, and it sparked a lot of conversation. It sparked a lot of discussion and questions, and it let me know that auth in GraphQL is actually kind of a difficult topic for everybody, and I thought maybe it'd be useful to build a talk that was all about auth in GraphQL from the back end. And it's true that auth in GraphQL can be really confusing, I think, especially when you get to the back end side of things. And I think part of that is because when we're building a REST API, we know that we're going to need to add some sort of middleware where, we have a whole bunch of different endpoints, and so we can just kind of slap a auth middleware on it and kind of call it good and move on. But then with GraphQL, of course, we just have this one big endpoint. And so it's a little bit less intuitive to know what we're supposed to do in order to secure our GraphQL endpoint. Do we just lock down the whole thing? Can we secure bits and pieces of it? And so that's what we're going to talk about in this talk. So Shruti already gave me a really nice introduction. I'm Sam Julien. I am a developer advocate at Auth0. We're an identity as a service platform. Basically, we handle the login and user profile and everything for your app. Try to make it easy for you so you don't have to worry about it. I'm also a Google developer expert, and I teach in a few different places. I make courses for Thinkster and also on Egghead. So in this talk, all of the examples and code and everything is going to be in JavaScript, but that most of this is conceptual. It doesn't really have to do with specific implementation. So it should carry over to whatever language you're using in your GraphQL backend. So in this talk, we're going to cover a couple different things. We're going to talk about just some auth background, get some terms out of the way. Then we're going to talk about the what and why of JWTs. And then we're going to talk about authorization in GraphQL, and we're going to walk through some code and things like that. So let's get some auth background first. The two biggest terms that you'll hear about with auth are authentication and authorization. So let's define those before we move on. So authentication basically means, are you who you say you are? Sort of proving your identity. And then authorization, on the other hand, is, do you have permission to access resources? And so if we think about those terms in the context of GraphQL, we have our user, right? And then we have our GraphQL backend. And if you think about it, the GraphQL backend is really just a layer over our database. So GraphQL doesn't really necessarily care if you are who you say you are. They just need to know what permissions you have or what access you have to the data that you're trying to request, whether you can read it and write it and that kind of thing. So typically, the GraphQL server doesn't necessarily need to care about authentication. It mostly needs to care about authorization because it cares about who has access to what. So we've talked about access. Let's look at that in a couple of different scenarios. Here's sort of a really standard common scenario where you have the back end and the front end on the same server. So for example, maybe you've got like GraphQL and Next.js on the same server. So you've got a back end and a front end coming from the same server. So the user sends their credentials over to the front end, and then the front end sends it back to the back end, and the back end creates a cookie and a session, and then sends that back to the front end. So this is a really common scenario, and that's a totally legit way of doing it because your front and your back end are on the same server. So there's an easily traceable path of the request and the credentials. But a lot of bigger applications don't do this. A lot of bigger applications, maybe you've got a few different, maybe you've got a backend server, and then you've got a bunch of different APIs in the cloud, and all of that is coming together in the front end. Or maybe you have an API gateway, and your API gateway is in front of a bunch of other APIs or services, like maybe a bunch of Lambda functions or something like that. And so then the issue of access becomes a little bit more complicated, because we're not just trying to get resources that are on the same server. We're trying to get access to resources in a bunch of different places. And so what we're concerned about really is this thing called delegated access, where we're trying to get resources on outside servers, not just what's hosting our front end. So we go back and look at this scenario, and then we have our servers and our APIs. What we're trying to do is we need some sort of thing to be able to verify that the user is allowed to access those things. And cookies don't really work for this. Cookies are really meant for doing things on the same domain with the same server. So we need something else. We need something that can contain useful information, but that also can be signed and verified. We want to know if we're getting this from a completely different server, how do we trust it? How do we know that this person has access? So what is this, and how do we safely create it? Well, what we're talking about here is an artifact called a token. And the way we create it is with an authorization server. So an authorization server is a server that basically helps make access control decisions in your app or your API. And one of the ways it can help with that is by creating an access token. So an access token informs the API that the bearer has been authorized. So the user checks out, basically. So the authorization server sends over this token to the front end, and then the front end sends it over to the API or the server, the GraphQL server in our case, and we can verify that everything is good and send the user whatever they requested. And this also works in the scenario of having multiple servers and with an API gateway. So an access token, you've probably seen it before. If you've looked at some request headers, you might have seen this authorization header with a bearer, with the word bearer, and then a string of a bunch of letters and numbers after it. And that's the token. And so we mentioned that we want something that can contain useful information, but that also can be signed and verified. So there's a format that's really convenient for this called JSON Web Tokens, JWTs. This is a commonly used format for an access token. It's not a requirement. It's not mandatory to use a JWT, but it's a very useful format for it. So JWTs, they tend to look like this. And at first, this looks nonsensical, right? It's just a bunch of letters and numbers, and it's kind of unintelligible. But it turns out what's happening here is this is actually JSON, and JSON that's been run through an encoding and then spit out to look like a string, basically. So because of that, we can store a bunch of information in it. And a JSON Web Token consists of 3 parts. It's got a header, which is the algorithm and the token type. It's got a payload, which contains all of the data as well as the claims in the token. And there are some that are mandatory and some that aren't. And then it's also got a third part, which is a signature. And this is what we can use to verify that the token came from the authorization server and it's meant for this particular API that we're working with. So now we've discovered a format that can do both the things that we need. We can pack information into it using JSON, but we can also sign and verify it. So an example of this that you might have seen, this is something that Hasura does, where it puts additional claims, or they want you to put additional claims into your JWT. And so you can create this section that has what's called a namespace. That's what that hasura.io/JWT/claims. And you can add a bunch of custom claims, and then that becomes part of the JWT once it's encoded. And so this will work with our scenario where we have our authorization server. It sends the token to the front end, and then the front end sends it to our GraphQL API. And so we talked about how GraphQL is mostly a layer over your database and isn't necessarily concerned with authentication. And that usually means that your user management will most likely live outside of your GraphQL layer. And that kind of leads to the question, should you just build your own authorization server? And this is kind of a hotly debated topic. In my opinion, I would suggest not trying to write that yourself. You can do some of the basics yourself, but when you get into it, you start to realize there are quite a number of things that you need to take into account, like proper password controls, and what about brute force attacks, and how do you make sure that there's correct error messages? It's a lot to keep up with. So I would suggest outsourcing that piece of your app. I know you're probably thinking like, oh, of course, like you work for Auth0, of course you're going to say that. But it doesn't have to be Auth0. There's actually a number of these options out there, but I highly recommend if you're doing anything more than just sort of a sample app, if you're doing a bigger enterprise project or anything that's going to have a lot of users, you're probably not going to want to do the authentication piece yourself. Okay, so we looked at these different scenarios with multiple servers and an API gateway. So now let's get a little bit more specific and talk about authorization in GraphQL. So before we get into this section, I want to have the caveat. I feel like anytime you give a talk on backend stuff and data, like there's a lot of nuance and complexity in application backends and how data is structured. So consider these sort of guiding or signposts or suggestions. Obviously, the specific implementation and the design decisions, the architecture decisions you make are going to vary greatly depending on the state of your data and the priority you give to different things. But these are good starting points for you. So when we're going to get the token in our request, the incoming request to the server, it's going to be attached as this authorization header, and we're going to need to pull out the bearer token. And so then what we need to do is the GraphQL server is going to need to verify the access token with a public key. So remember we said that the token was signed. What happens is it gets signed with a private key, something that only the authorization server knows. But the authorization server also has this public key that other places can verify it and say, oh, yep, this actually did come from this server. And then once we do that, we can parse the claims out of the token for the authorization. So that's what we need to accomplish in our GraphQL server. So how do we do that? Well, first, we're going to grab the token from the request and add it to the context. So what we can do is we're going to use Apollo in a lot of these examples, but you could really, it doesn't matter. You could pull this out of pretty much any GraphQL server. You can pull the token out of the request headers and then do something with it. So we've got our token, and now we need to verify that it's a properly formed and signed token that came from the right place, and then work with it from there. So we need to create this method called verify token that's going to receive the token and then give us back the payload of the token, the decoded payload of the token. So remember, it's going to be in this format where it's going to say bearer, and then it's going to have the token. So we need to split out the actual token. We don't want that bearer. We don't need that bearer word in there or the space. So we can split on the space and then get the token out of there. And then we need to verify the signature. So how do we do that? Well, there's a technology called the JSON Web Key Set that we're going to use. And there are libraries out there that can basically do this for you. Your authorization server will have an endpoint, a publicly available endpoint that will list out the public key that you can use to verify the token. So what we'll do is we'll grab that from wherever our authorization server tells us to. It's going to have this .wellknown/jwks.json at the end of it. And we pass that into a third-party SDK that can help us make that call. So basically what we're going to do is we're going to call that endpoint and then go get the public key and return it. And then once we have that, so we're going to create this we're going to call a verify function on a JWT library out there and pass in the token along with the public key. And then we're going to need to provide a few other options that will be used to parse out the payload from the token, like the audience of the API and a couple other things. And what will happen then is we should get our payload return from that. And if we don't get our payload, then we'll just throw an error and say that it's invalid. So an invalid token can come from either something that's not properly formed, or maybe somebody's trying to hack a token and form something themselves and they don't have the public key right. And so we'll want to let people know that it's an invalid token. So now we have our verify token function. And by the way, I'll have a link at the end to all of the slides and a whole bunch of resources. And part of the resources, I have an example of Apollo server and client that has this verify token function in it. So you can actually go look at some code. It happens to use Auth0 for the authorization server, but it actually doesn't matter. You could use it with any other authorization server. So where do we want to use this? We could use this inside of our resolvers. Every single time somebody makes a call, we could verify the token in our resolvers. But if that feels weird to you, it does to me too, because that means we'd have to reuse this over and over again. And that doesn't seem like it makes much sense. So the best place to do it is really in the context of our server. So in our server, we can create this create context function. We're going to initialize a couple of variables for the token and the current user. And the reason we're going to initialize them with some null values and just return them no matter what is that sometimes you might have a public endpoint or something where you're not going to require a token. So rather than erroring out every single time somebody tries to hit the server without a token, it's a little bit better to take that into account. Now, if your API does only have private endpoints, then you don't need to worry about this. But often you want some sort of public endpoint, even just to say or a public resolver of some kind, just to even be able to do some testing. So then inside of our function here, we're going to try to get the token from the headers. And then if we have a token, we're going to call our verify token. We're going to await that, get the payload, and then we can do something like grab the user from our database somewhere. So when I showed the slide of the parts of the JWT and the different claims, one of the claims is called the subclaim, and that's basically the user ID that's being used. So you can grab that subclaim off of the token and pass that into your database and go grab your user. So this is just one example of doing that. And then if there's something wrong, we can throw an error and return a 500 or something. Otherwise, we'll just go ahead and return the database and our token and our current user. And so then what we can do is use that create context function when we create the instance of our server. So we'll have our context and then pass the request into that create context function. And that's what will allow us to have access to the payload of the token and the user throughout all of our resolvers. So for example, let's say we had a create event, let me back up a little bit, create event resolver here with our standard arguments of parent args context at info, and we check to see if we have a current user on the context after we've grabbed it from the database with our token, and if not, then we'll throw an error. If we do, then we can pull that current user off the context and go check their permissions, see if they have the permission to do that, to run this function in the resolver, and then go create the record in our database. We can make this a little bit more elegant using composing resolvers. So we could pull out our isAuthenticated function as a higher order function, and then check for the context, and then return the next part of the resolver. That's a totally valid way of doing it. We could also pull out the has permissions check, the check for the permissions. We could pull that as a function as well, and then wrap our resolver, wrap our create event in the isAuthenticated, and then check for the permissions and go and create the record in the database. And so here's an example of what that check permission higher order function would look like, and then we could just wrap isAuthenticated and check permissions around our database call. There are a few different libraries in the ecosystem that I just want to point out that will do some of this for you. One is called GraphQL resolvers, where you can just easily make an is authenticated and then return either the current user or just skip to the next resolver. And that's pretty useful. And then you have this nice combine resolvers function where you can just piece together and compose the different resolvers that you want. So you could have one for is authenticated, and then one for check permissions, and then the final resolver, which is the creating the event in the database. Another approach to this is through GraphQL modules. GraphQL modules does this nice thing where you can do this resolvers composition. So when you come to the create event mutation, then compose together is authenticated and check permissions before you call the rest of the create event resolver. Another approach to this is middleware. So one is GraphQL middleware. You could make this a little bit more elegant by having some is authenticated middleware and then passing those in as an array when you create your server. And in fact, there's actually another library that's built on top of this called GraphQL Shield that's exactly for this purpose of permissions. There's another approach, though, to doing this authorization, and that's through custom directives. So rather than trying to do this in your resolvers, you could check these permissions with a custom directive. So you've actually seen these before. For example, deprecated is actually in the GraphQL spec. And so you might see on a piece of data that you're trying to get, you might see, for example, here we've got this event location has replaced the location field, and you have this deprecated directive on there. So you can actually create your own directives and do whatever you want with them. And directives have a few nice things about them. They're part of the spec, so it's an official, supported thing to do this. What they're really good for is changing behavior at runtime. And because of this, they have a lot of different applications. For example, this is great for internationalization when you have to change strings on the fly based on location and things like that. And so we can do this with our authorization as well. So we can use custom directives to actually control access down to the field level if we want to. So let's look at the anatomy of a directive. First, you have to give it a name. So here we'll give it has permission. Then you give it an argument. So we're going to give it a permission that is a string. And then you need to tell it where to actually use this directive. Here we're going to do it on the field definition, but you could also do it on the object and a couple of other different places. And so then we can define, we've got our directive defined, but now we actually have to tell our GraphQL server what to do when it comes to that directive. So this is, again, this is Apollo and GraphQL tools as an example. But basically what we do is create a class that has this visitor class. And we are essentially just saying, hey, when we get to a field that has this directive on it, what we want to do is pull that permission out of it and then grab the field out of it and check to see if we have our user. If we don't, then we're going to throw an error and say that we got to be logged in. If we do, then we'll call that has permission, check for the permission that's been passed in as the argument to the directive, and either resolve it or throw an error. And so then when we create our schema, then we'll pass in the has permission with that has permission directive class into our schema directives object. And so what's nice here is now when we create a mutation, when we define a mutation, we say, okay, we've got this create event mutation, and it's going to return an event, and we're going to add this directive, this has permission directive, and we want to make sure that the user has the permissions.create permission. So it's a really nice, refined way of doing these things. There are a couple of downsides to using custom directives for authorization that you should be aware of. One thing is that it couples your logic to your schema. And so it's not necessarily a bad thing, but it's something you want to keep in mind because it makes it slightly more difficult to modify your schema if you've already got logic tightly coupled to it. So it's just something to pay attention to. Another thing you want to keep in mind with these custom directives is that they can be quite difficult because you might forget, it's at such a low level in your schema that you might miss some edge cases. So you might have to do quite a lot of testing to make sure that you've defined it in the proper way and that you've taken into account different edge cases and things like that. So powerful tool, and as the cliche goes, with great power comes great responsibility. Since we don't have a ton of time for custom directives, there are a lot of resources out there. Ryan, who just talked, gave a nice talk at GraphQL. I think that was GraphQL Summit a couple years ago, 2018. He gave a great talk on that. Also, GraphQL Asia that just happened in February. There are actually several talks that talked about custom directives, and some of them talked about authorization specifically. The Apollo docs also have the Apollo server docs also have some information on enforcing permissions with custom directives. So hit you with like a ton of information. So let's just do a quick review here. We talked about how GraphQL is a layer over our database, and so it's mostly concerned with authorization and access to data more than it's concerned with the authentication piece. We gave the example of regular access of GraphQL and Next.js on the same server where you could use a cookie and everything kind of is hunky-dory, but it's not quite going to cut it when we have multiple servers or an API gateway. And for this, we're going to need delegated access. And so in order to do that, we have an authorization server that will create a token that gets sent to the front end, and then the front end can send that to our API and verify everything, and then check the permissions of the user. A great format for an access token is a JWT. A JWT can store information. It can also be signed and verified, so we know for sure that it came from the right place. We talked about how the best place to check for the token, to pull off the token and get the claims, is in our context function. We can do this in context, and then in our resolvers, we can do things like check to see if we have a user and if they have the right permissions. We also mentioned a few different libraries that make this a little bit more elegant. We have GraphQL Resolvers that has this nice combine resolvers function. We also have GraphQL modules that lets you do a nice resolvers composition where we can just tell it, hey, when you come to the create event mutation, run these other ones first, the is authenticated and check permissions. And also we talked about GraphQL middleware, where we can have an array of middleware that we can attach to a mutation. Lastly, we talked about custom directives. We talked about creating a has permission custom directive on the field definition that then we could attach to our mutations. So to close out, I wanted to mention, some of you have probably seen this podcast that Nader Dabit runs, GraphQL Patterns, and they have a couple of great episodes on auth that I highly recommend checking out. And they have a couple of nice parting words for us. One thing is that you want to remember that good schema design is the most important thing. As with any backend and data design, it's kind of garbage in, garbage out. And so if you design your schema to require only as much auth as needed, sort of that principle of least permissions needed, that will make your life a lot easier. Another thing you want to think through is whether auth is needed at the object level or the field level of the different pieces of your schema. Lastly, don't design mutations that can change arbitrary objects. Make sure that you're being specific in what mutations are being done and what users are allowed to do them. And one last thing is to experiment with sending null values instead of throwing errors. This is another one of those trade-offs. On the one hand, throwing a lot of errors is not a great user experience. You could send some null values instead. But the flip side of that is that null values don't really tell you a lot of information. They don't let the user know anything. So it's another sort of dial to turn up and down depending on what you want in your design. So like I mentioned, I have all of these slides. I have a bunch of sample code, a bunch of resources, all at samj.im/GraphQLauth. And I just really appreciate you all, and hope you have an awesome rest of your day.
That was a great talk. I learned so much.
Awesome.
I especially like the bit where you said garbage in, garbage out.
Yeah, it's
And design
definitely
with.
yeah, it's definitely the case with backend design. The database is the key.
Yeah, and especially the bit about design with auth in mind, specifically like whether you want field level auth or object level auth, and I think that is very important to think upfront as well. So yeah, I think super helpful.
Yeah,
Uh,
awesome.
let's see if the chat has any questions. If you guys have any questions, please leave it for Sam. Sam, what did you use to make your slides? Those were pretty neat.
That is all Keynote.
Really?
Yeah, yeah. I have some tips and tricks for Keynote with the way to animate that code and things like that. Yeah.
Yeah, that was pretty neat. I thought it was like what is that, slides.com or something? But yeah, that's awesome.
Yeah.
So looks like the chat doesn't have any questions. So Sam, you're officially off the hook.
Excellent, excellent. Well, thanks everybody for having me. It was great to be here.
Thanks, Sam. Thanks so much for joining us.
Yeah, so that was a really good talk, and Samit has a lot of knowledge about like GraphQL back in JWT, so that was great. So maybe we can kind of like close this off, right, Shruti? And I'm sure you have like another like dev joke, but that'd be great though.
Okay, here's an easy one.
Okay.
Why was the JavaScript developer sad? Okay, I take back easy.
Can you repeat?
Why was the JavaScript developer sad?
I personally, I don't know that. Let's see if someone can answer. Nobody.
I'll give it another minute.
Because he didn't have any type.
SAD?
What that means? I don't know what that means.
I don't know what that means. Why? What does it mean?
Okay, like meanwhile, the people like I have another. I think this is my favorite dev joke, which is how do you convert a JavaScript bug? That's a really good one. I'm gonna
That's my favorite too.
ask again. How do you convert a JavaScript bug? I think that's a really good one. Because now I just found like the first job that you did.
Did you just Google it?
Why is the JavaScript developer sad? Because they do not know how to spread themselves. They do not know how to express themselves. Okay,
Good job.
Oh, Ramyak, he knew the other one. He's probably in the repo. So yeah.
You console it. That's right.
You console it, yeah. That's a good one. That's like
He does not know it.
Yeah, okay. Yeah, so I think like we can close it off for today. It was a pleasure to have like everyone's like Cahill, Ryan, Sam, of course you, Shruti. Thanks so much for like coming over and like having a lot of fun with that with everybody's.
Thanks for having me.
Yeah, no worries. Yeah, like always welcome. So it'll be great to have you again anytime. So I gotta say before like closing the live stream, we are gonna have another GraphQL Madrid meetup next month. It's already scheduled. I haven't announced it yet, but it's gonna be kind of like end of September. And we have another like 3 incredible talks with swag, and hopefully we are gonna have also a lot of dev jokes as well. So just to say thanks everybody for joining. Hope that you have learned and you have had a lot of fun, and hoping to see you again. Have a great day. See ya.